Hello and welcome to the Aegex Webinar. Today our guest host is pureLiFi, and we will be hearing from the company's Vice President of Standardization Business Development, Nikola Serafimovski. First, before we begin, I'd like to direct your attention to the GoToWebinar control panel. You'll see on your panel you can go to the section called questions and type in your questions there. We will save about 5 minutes toward the end of the presentation to take your questions. And if we don't get to your specific question during this session, we will follow up with you by email. I'd also like to point out that there are a few handouts that are available for download containing information about pureLiFi. So I would like to also introduce to you Thomas Vincilette, the President and CEO of Aegex Technologies, who will give an introduction.
Thanks, Lee. I appreciate everyone joining today. This is a very unique opportunity to introduce a partner that I think is going to be very impactful in this industry. Obviously, in doing what we do as far as making devices for hazardous environments, as most people are well aware, those environments create very, very unique challenges. Connectivity and communications being a key part of that. And getting a device to communicate so people have access to real-time information in an environment deep in the base of a refinery, in areas of offshore rigs, or any number of other locations where RF signals just simply will not permeate, or it's just simply too expensive to create such an infrastructure. pureLiFi, a company that we found up in Edinburgh, has probably, I think, the most remarkable and unique approach to this. We see this as impacting so many different areas of operations for organizations, providing a tremendous, secure, high bandwidth capability in areas that really weren't options in the past. Not to mention the fact that it just is simply cool and remarkable. We get a chance to see lots of fun technology, and what Nikola is going to go through with everybody, you will honestly believe it's not possible, but it is not only possible, it's exciting, it's innovative, and I think it enables all of us to do things that just frankly just a few years ago was something way too out in the future. So Nikola, I really appreciate you joining us today and look forward to it, and so I'll hand it to you.
Brilliant. Thanks a lot for that very kind introduction, Tom. And I'm very happy that cool is the word that's being used. It is always a good thing to be a cool technology. So I will try to maintain a semi-structured approach to this presentation, and I'll try and leave as much time at the end of it for questions and answers as possible. So thanks everybody for joining us. The first thing is LiFi. For those of you that haven't heard, LiFi is high-speed, bidirectional, and fully networked wireless communications using light. So what this means is basically imagine that every single light is a wireless access point, and imagine a substantially similar user experience as you currently have with Wi-Fi and other type of RF communications, except using the light spectrum. That's what we want to achieve. So a little bit about our company. pureLiFi was founded by Professor Harald Haas. It was established in 2012 as a spin-out from the University of Edinburgh, with really a focus on developing this concept of LiFi. The term LiFi was first coined by Professor Harald Haas during his inaugural TED Talk back in 2011, and outlined the vision of where we would like to see. We are headquartered in Edinburgh and have multiple sales locations in North America, Asia, and Europe. We started off with just 15 people a couple of years ago, and right now have over 52 different positions. Very, very interesting, very cool people working on the innovation, development, and commercialization of this core concept. So what I would like to just draw your attention briefly, if you see that middle picture between the lovely blonde lady that's smiling and the person right next to her that's resting his arm on that cabinet. So that cabinet that's basically this about a meter, so about 3 feet tall, was the very first TED demonstrator that was used to show the concept. And throughout that picture, you can see various instantiations of our product set, including some of the latest integrated luminaires that we're developing and building. So we've really come a long way from a big TED cabinet to something that is really a USB stick. Our leadership team is Alistair Banham, who's our CEO. He's got extensive experience in the semiconductor space with senior roles previously in Motorola, Philips, and so on. Harald Burkhardt, who's our Chief Commercial Officer. He's really led the company through our first Series A with Temasek as one of the key investors. Mustafa Afghani, he's our CTO. He is also the co-founder of pureLiFi and is really the technical brains behind our operation. Professor Harald Haas is our Chief Scientific Officer, so apologies for the typo there. And he the visionary within our organization, just there on the bottom left. And our finance director is Jill Goldsmith, helping us stay in check and not say yes to too many things. And lastly, Mike Hickey is our chairman, who's really helped us focus in and help achieve that strategic vision. We are the inventors of LiFi, we're the leaders of LiFi, and we're looking at maintaining that edge as the technology develops and becomes a more widespread technology. With decades of experience in the mobile and semiconductor industry, we really think we have the core capability set to drive LiFi into its strategic focus, which will be a completely pervasive and immersive user experience. So as I said, Professor Harald Haas coined the term LiFi, and he's been working with the company he's been working on the technology for well over 14 years now. And he also leads the LiFi Research and Development Center with the University of Edinburgh that pulls together a whole host of different parts and different elements, not just pertaining to the light communication piece, but also the wider implications with respect to the network topology, management of those networks, and so on. LiFi adoption is real. Many people, when they hear about the concept, still think it's in the early stages, but actually, pureLiFi alone has over 65 deployments in 20 different countries, servicing 16 different use cases. These range from POCs through to business-driven, articulated value for that end customer that is currently being monetized to their benefit. This is the core element. The technology is no longer a pipe dream. It is no longer a lab environment. It is here, it is servicing end customer needs, and it is scaling very fast. So what is it? Well, it's real mobile wireless communications through light. As I mentioned, when you think about mobile communications, what do you want? You want to have the phone, you want to press a button, which means you need to send the signal from that device to the internet, and you need to then pull information down. So it's that bidirectional nature using the light spectrum. It's fully networked, which means I can move from one light to another and maintain that seamless user experience. So if I have a Skype video call, for example, and I move from one light to another, I would like that call to continue. High speed, of course, it has to be useful for what we're doing today, but also where our communication needs are going into the future. And we really need to use the light spectrum because that's a core differentiating characteristic that allows us to address a whole host of use cases, including deploying the technology in severely RF sensitive environments. In brief, LiFi uniquely combines the mobility of wireless communications with the security of wired communications. That secure wireless communications to a level that we believe is in certain ways superior to a simple wired connection, and also offer that same flexibility of a wireless solution. If we look at kind of what the key differences between radio and light, it is containability. So light is visible, you can see it. If you use infrared, you can't see it, but it's still containable. It has a very limited propagation aspect, which the British have this beautiful saying, it's called horses for courses, right? It means using the technology in the use cases where it makes most sense. So if you want to cover large areas with very few users in that space, you want to use radio. It's what it's designed for. But if you find yourself in an environment where RF is not allowed, different oil rig elements or production elements or industrial environments, or simply the environment for RF is very hostile, then light becomes a very, very attractive alternative. And of course, let's always remember, because light is so contained, there is a very hard limit to who can receive that signal. For those of you that are into security, you have probably witnessed and seen newspaper headlines about the crack vulnerability that was found out on Wi-Fi not too long ago. And you would have seen a number of different exploitation elements of how wireless networks can be cracked. And in fact, this vulnerability, this fear that your RF signature is being picked up, not just by eavesdroppers, but can potentially be used against you disruptively, prevents the deployment of wireless communications in numerous environments. That's where light has a unique advantage. So how does it work? On a very, very simple concept, LiFi is a Morse code on steroids, right? So we have the traditional communications backbone, right? Each light is a LiFi access point. It is connected through a wire that delivers both power and data to the unit. That is then connected to switches and servers, internal and as well as the internet external. The light, the access point, those small boxes that are above the light, are changing the intensity of the LED light. So effectively dimming it down and bringing it back up. They're doing this dimming at rates that are significantly faster than what the human eye can see. And by changing the light intensity, we can convey a communications signal that is not visible to the human eye. In fact, not even visible to very, very, very high-speed cameras, but is visible to our USB receivers, which are then used to detect those changes in the light intensity and convert it into a meaningful data signal. For the uplink, it is exactly the same concept, except we're using an infrared LED to go from the user device to the access point in the ceiling. Why do we want to do this? In short, security is a key element. Not only does the containability help limit the propagation of the RF signal, but it also ensures that you can now use the location as part of your network authentication principles. So if you think about traditional cybersecurity, it's built on kind of three pillars. Someone I am, which is usually based on certificates. Something I know, which is typically passwords or second factor of authentication. Something I have, maybe, if you have dongles that have a particular type of connectivity. And between those three general elements, then you can build a whole host of other network security capabilities. Well, with LiFi, we're really introducing a fourth element. It is somewhere I am. Being able to use the location, the specific origin of where that communication is coming from as part of that cybersecurity portfolio, as part of that signature of that communication, is absolutely key to better information assurance for stakeholders in the entire value chain. There is no interference. Anywhere there is light, there will be LiFi one day. Radiomagnetic waves of all sorts live happily amongst each other, but if you're using traditional RF, they can create issues with various electrical and control systems. In the defense space, that could be fire control, which can have devastating consequences, or in the machinery space, if you create any kind of induced currents in any of your control circuits, can also have devastating elements. But with light, that interference is not there. It is very easy to simply block out the light from areas where you don't want it and allow light in areas where you do want it. The no interference element is also very interesting to improve the security. So if you think about an automated factory, for example, or an automated oil rig, you can have a very inexpensive drone fly up to a sensitive environment and create an RF jamming field that will effectively block out a very, very wide range of the EM spectrum. If you're talking about a fully automated environment, this can have devastating consequences, not just to the production capacity of that entity, but also potentially to human life, depending on how everything is connected. Blocking and interfering with light is substantially more difficult. And even if one light is blocked out, the remaining elements will still continue to function. And when the blocking happens, it is very easy to identify and effectively mitigate that threat vector. Data density is the next element. So again, if we look at the world that we live in currently, wireless communications is expected to continue. The demand for wireless communications is expected to continue at approximately 60% per year. Well, that's perfectly fine, and that's great. We want everything to be wireless. But the reality is we don't really have the spectrum to allow for that. If you try and place too many Wi-Fi access points next to each other, you will not add capacity. You will simply cause more interference. And if you think about this concept scaling to the Internet of Things, where you might have hundreds of sensors in a very small space, you can see how that quickly becomes potentially a problem. Well, with light, because it is contained, you do not have the same interference between one light and another, which allows us to reuse the entire light spectrum in a much denser context. Again, if we just look at a normal office, you might have all of that space communicated and connected through a single Wi-Fi access point, or 2 or 3. But in that same space, purely for illumination purposes, you might have 20, 30, 40, 50, 100 different lights. This allows us to significantly grow the data density, so the data rate per area within any given space. And this is very unique to LiFi, which can bring in orders of magnitude greater data density, so megabits per meter squared, in any given environment. Location services is another aspect that is absolutely key. Again, if we talked a little bit about the cyber advantages that can be leveraged from knowing the origin of a particular piece of information. Well, not only do you have that advantage from a cybersecurity perspective, but now you can start building very reliable, robust, location-based services. So if you think about, say, nuclear power plants, right, or any kind of very large industrial areas where you might still have manual checks, if you're walking around and you're looking at a piece of machinery that you need to maintain, how do you know what is the latest status of that piece of machinery? How can you reliably tell that the person that came before you in that 100-meter long corridor took the left turn or the right turn? And how can you make sure that the history of the item that you're looking to maintain is accurate? You can use the location very reliably with LiFi in these hostile RF environments to not only provide a communication piece, but to provide the relevant communications for the relevant person in the relevant time. This is absolutely key in these types of environments. But similarly, you can start building additional services once you know how people's movement is and how your assets are being managed and maintained, which allows us to really build significant business value by providing accurate, location-relevant information for the owners and operators. And of course, we talk about efficiency. So again, going back to the growth in the demand for wireless communications, well, as it turns out, the vast majority of the power that's enabling our wireless communications, that is pretty much equivalent from a carbon footprint standpoint of view to the entire aircraft industry. So the wireless communication alone consumes about as much energy as the entire airplane communications, right? Getting on a jet and flying to Florida. That's a huge amount of energy. So how are we going to mitigate that if we want to maintain the exponential growth in our wireless data availability? There's one source of energy actually that is, there's one source that is consuming even more energy, and that is lighting. So lighting accounts for approximately 13% of all of the world's electricity consumption from a consumer perspective, right? Lights are on for our ability to see. Well, why couldn't we use all of this energy that we're wasting anyway to also provide wireless communications? That is uniquely enabled by LiFi. And with this focus on growing smart lighting, growing LED lighting becoming pervasive, more and more connectivity being brought onto those LED luminaires, sensors, occupancy presence, temperatures, etc. LiFi is a natural progression, a natural service that can be brought into this lighting world to really enable a new generation of service creation and a new generation of service offerings for that entire industry. The traditional business model of replacing LED lights or replacing tungsten and fluorescent lights is gone with LEDs. So the lighting industry needs to develop new and more innovative business models that are sustainable for the future. And LiFi offers this really unique opportunity to achieve that. And of course, by combining LiFi in their infrastructure element, you can see how very quickly LiFi will be able to scale across the globe. So those are some of the advantages, and we talked a little bit about what the technology is and about who we are. So let's look at some of those applications in the real world. Security obviously is a key driving force. And I think in this context, I can reflect to a very specific case study. We've deployed a number of times with different organizations. One of the key deployments to demonstrate the difference between RF and LiFi was first demonstrated at Joint Venture 2016 with the British Ministry of Defense, as well as Cisco, BT Defense, and a few other organizations. Joint Venture 2016 was a key deployment of UK forces to assess readiness. In this particular environment, we were looking at a secure deployed headquarters. And as a trial, the end customer wanted to see how does LiFi compare to Wi-Fi. So we deployed in a tent with a number of staff users who were to work off of a wireless system using the cutting edge of wireless connectivity and flexible working. This includes cloud services, Exchange Point, SharePoint, and Skype, and so on and so forth, collaborative working tools. Well, we had LiFi and Wi-Fi running simultaneously for a number of days with no problems. On the day of the exercise, when the heat of battle happened, Wi-Fi stopped working. No one knew why, no one knew how. And you had about 4 different Cisco expert field engineers running around trying to figure out why this system went down. It has nothing to do with the Cisco system. Any RF system would have gone down. It was a very simple jamming device that was perpetrated by one of the staff sergeants there who had brought in a $100 dual band 2.4 and 5 gigahertz Zigbee jammer and just pushed a lot of power through it. With $100, they were able to effectively deny all wireless operations. LiFi was unaffected. The exercise continued and completed successfully because you cannot jam it, not in any meaningful way. In fact, not only could they not jam it, but we had signal intelligence units that were looking for the RF signature, and they couldn't see anything, even from one grid position away. Very, very important. RF hostile environments. So we're working with a number of organizations to show the business benefit of this technology. What if you could connect sensors to a whole range of pumps and actuators and I don't know, sensory, other sensors, you know, temperatures, pressure gauges. What if you could fully enable, truly enable an IoT environment in the most hostile of spaces, whether that's oil and gas or nuclear or any other kind of industry environment, without concerns for the security of your data and the jamming effect? We've done that, and case studies on this will be published shortly, we hope, as soon as we have some approval from our end customer, to illustrate some of that groundbreaking work that's being done and that the value that is being delivered to the end customer. Enterprise solutions. In France, Sogeprom and Nexity are two of France's top 3 property developers. They have deployed LiFi in their headquarter buildings, in their flexible working environments and secure office spaces to drive the security element, the privacy element for their customers, while giving them the flexibility to rearrange the space as and when necessary. It is that reliability and security that has driven the use and deployment of this technology in real life with real customers for their business benefit. Smart transport. It is easy to envision cars connected to each other. Again, if we look at various types of environments, you might not want to be connected to an RF backbone, whether that's for security or safety. But with light, you can connect every single street light. Every single car can be connected to another car, and you can enable easily that dream of vehicle-to-vehicle communications without considerations for the interference that might be coming from other RF sources, or again, the jamming, because a kid wants to have fun with their latest toy and just experiment with how much damage they can wreak to an intelligent transportation system. And lastly, smart cities. You can imagine how LiFi can easily permeate the hundreds of thousands of streetlights to provide that connectivity for the users. As the density of city living increases, as the privacy and security of user information becomes ever more relevant, LiFi is a key enabling technology that can allow us to do that. And from that perspective, we really see a core, we really see the technology as being core to the future of smart cities. Eventually, LiFi will find its way in the smart home. What if your kettle wants to connect to the wider communication system? What if your toast wants to be ready on time? These are trivial examples of automation. But the reality is, as we add more sensor nodes in our homes, more of our personal information can be compromised. More of our routines become known. More of that interference becomes a problem. LiFi is a key technology that can easily scale to address dead spots in homes, but also improve the security and privacy of the users so that we can have an automated home, but at the same time, we can quite literally lock the door and know that just like in the past, our valuables are safe in our home. So what does pureLiFi offer? Today, we have our LiFi XC dongle. It runs on USB 2.0 devices, supports Windows 7, Windows 10, Linux, and Mac with high performance optics and a 60-degree field of view. It is a plug and play solution. Yes, you need to install drivers, and yes, you need to allow that connectivity. But once the drivers are installed, you plug the dongle in, and it just shows up as another Wi-Fi connection. It is extremely simple for the users to absorb that and really derive value from the connectivity without worrying and constantly checking how it works. The LiFi XC dongle, of course, is paired with an access point. As we briefly mentioned in the beginning, we need the light to be LiFi enabled, and of course we need the devices to be LiFi enabled. The LiFi XC access point is largely LED agnostic. What that means is we can connect a whole range of different LED lighting fixtures without sacrificing that performance, which means you no longer need to go out and look for specific lights, but rather the technology can adapt to the environment that is necessary. It mounts, the LiFi XC mounts above the ceiling, connects to the LED light, and is pretty much non-existent from an aesthetics perspective. It's able to very flexibly fit to your backhaul and supports both power line and power over Ethernet communications. That is absolutely key. If you think about what power over Ethernet can bring, especially in an enterprise environment, where some of the smartest buildings in the world currently are using power over Ethernet. I think a very prime example is the Edge building in Amsterdam. It has over 6,500 PoE connected lights and was 50% faster to install and 25% cheaper to install. That has huge implications, and LiFi just fits nicely into it. It is very important to remember that the business case for installing PoE in buildings has nothing to do with LiFi. It is happening in its own right. LiFi is just a perfect technology that will fit and really use that available capacity. So all of these elements are very cool, but the reality is, before a technology becomes a true mass market, it will require multiple vendors. It requires an entire ecosystem that will support and drive the technology, from chipset vendors through to device manufacturers, through to lighting manufacturers, end customers, and more. And that's what we're doing. pureLiFi is driving the standardization of this technology within the IEEE 802.11. The IEEE 802.11 is the same group of people that standardize Wi-Fi. And keep in mind that Wi-Fi currently accounts for over 53% of all wireless communications, and that number is likely to increase in the coming years. Within that group, we have formed the IEEE 802.11bb task group to standardize light communications. And we chair the study group and are hoping to continue to drive forward in a leadership position the task group as a complementary bearer to 5G and completely interoperable with Wi-Fi. Individuals from all of these different companies are supporting this effort to help us come to a converged solution, to make sure that the industry is working to the same heartbeat, to the same schedule as everybody else. So when the technology is ready, the market will also be ready. And that's key. That is what standardization allows, is the unified march towards making LiFi a global success. Lastly, pureLiFi and Aegex are really working together to determine the viability of a fully integrated Aegex LiFi enabled tablet. And I think in this context, we are always keen to understand what benefit this integrated device will bring and to understand what pain points it can help solve. With that, I'd like to say thank you very much for your time and any questions.
Yes, thank you very much, Nick. We do have a couple of questions. The first one actually relating to what you just mentioned about Aegex. And they ask, how does this pureLiFi solution integrate with Aegex intrinsically safe tablets or Aegex IoT sensors? And maybe, I don't know if Tom might want to answer that, or Nick, either one.
Yeah, Tom, please.
So we are working down the path. Thanks for the question. We are working down the path of getting this, getting the LiFi dongle fully integrated into the tablet. So it's a complete integrated solution, certified under all the standards. As anybody is operating in that environment, as they step into that dome of that light, they've got that high-speed, secure connection. The second piece is also integrating the capability into the forthcoming new sensors. And so again, as that device sits out in that remote location, the light is there because those are routes for people to walk and so forth. And so the sensors are continuing to monitor everything live using the light as the air interface or communications path. All of it, of course, being certified under all the same standards.
Excellent.
Yep,
okay.
exactly.
Yeah. Do you have anything to add to that, Nick?
No, that sums it up pretty perfectly. I think that is the key aspect. We really hope to, if the consumers decide and if the partners decide that there is value in this, we really hope to introduce that unified system solution so that you can just install one driver or on a device, have LiFi enabled lights, have Aegex tablets and Aegex sensors that will seamlessly connect to that lighting infrastructure and really allow that business benefit to be drawn.
Excellent. There's a couple other questions. What if something is placed between the transmitter and the receiver? Does the transmitter have to be pointed at the receiver? And I guess
okay, so yeah, so I think we're not magicians, right? We're just very good engineers. If you block the source of the light, you will block the transmission. Depending on what you put in the middle between that communication channel, it might work, it might not work. But if you block the light, certainly you will block the communication. And in terms of the line of sight element, yes, it would be preferable to be line of sight, although you can design solutions where the system can work off of reflections if necessary. But I would say principally it is a line of sight solution.
Mm-hmm. And there's a similar question that asked, what if access points get dirty, partially blocking the light? And that's a concern in the oil and gas market, for sure. So again, is this the same sort of answer?
Yeah, so it depends on how blocked they get.
Mm-hmm.
With our LiFi XC system, we've shown that it can work in a very, very wide range of illumination scenarios, from a few thousand lux, for those of you that are in the lighting world, down to about kind of 50, 60 odd lux. And that's pretty dim. So I think if your light is blocked to the extent where at full power it provides such a dim output, then it anyway becomes a maintenance issue because of safety, because people need to see in that location. So there's quite a wide scope before that becomes an issue. But almost certainly, again, if the light is blocked out entirely, then you will lose that communication ability.
We have one more question. How does bandwidth degrade as the light is becoming more completely blocked?
I think that's a very interesting question. Honestly, it depends a lot on the signal strength, right? So it depends on the number of photons. But basically, with our system, you go from kind of full throughput of about 40 megabit per second down to a few megabit per second as that light decreases, and then you lose entire connectivity. Now, honestly, it depends on the use case before I can provide you any specific data, but at one point you would just lose entire connectivity if you fall kind of, let's say, below 50 or 60 lux. And lux is really a measure of the light intensity. So that's what I can give you. Depending on how blocked the light is, will have a direct impact on the amount of light that's output and then received at your station.
Okay, and the last question was, what are the sensors, the IoT sensors that Tom mentioned? And I'll let Tom just very briefly talk about that, but as it relates to this pureLiFi issue. Tom?
So specifically, yep. So specifically, as an alternative method of communications, LTE, Wi-Fi, or whatever, using that existing infrastructure, so a whole additional infrastructure of communications doesn't have to be installed, using that existing light infrastructure. Also, from an RF standpoint, getting into those areas where an RF signal is just never going to get into without significant install expense, using that backhaul as the method of communicating to the sensor. That's the objective there. The specifics around that, actually, those documents will become public in about a week and a half. So very large announcements coming in the next week and a half about the whole new range of sensors and how light becomes a part of that communications method.
Great. With that, yes, I will just add to that Aegex is exhibiting at the eChem Expo 2018 conference in Tennessee next week, and we will be debuting these new IoT sensors at that show. So if you're able to join us there, please do. And if not, we will be broadcasting all of that information in the coming week. Like I said, debuting at that show. So again, thank you all for attending. Thank you, Nick and Tom, as our speakers. And if we did not get to your question during this session, we will respond to you via email. So thank you so much for your attention, and we'll look forward to next month's Aegex webinar. Thank you and take care.
Thank you so much for the invitation. Have a nice day.
Thank you. Bye-bye.